Hari Om students, as I have told you that we will begin the new topic, that is ellipse. So the definition of ellipse is written over here. The locus of a point in a plane which moves in the plane in such a way that the ratio of its distance from a fixed point called focus in the same plane to its distance from a fixed straight line, which is called directrix, is always constant and which is always less than unity. So as you see, we have taken a point P x comma y whose coordinate is x comma y, and this point is the focus S, and this one is the directrix. So PS divided by PM will always be equal to constant quantity E, which is known as eccentricity, and its value is always less than 1. Means if this point P is moving anywhere in this plane, the plane of this paper, then always the ratio of the distance of this point P from the focus and the distance of this point P from the directrix, the ratio will always be equal to small e, which is eccentricity, and less than 1. This quantity is always constant. In the case of parabola, we have seen PS by PM is equal to 1, means E over there was equal to 1, means PS was equal to PM in the case of parabola. When we talk about the hyperbola, in that case PS by PM will be equal to E again, but in that case E will be greater than 1. Now in order to get the equation of the ellipse, I have drawn a tentative diagram of the ellipse over here with this one as the x-axis, this is as the this one is the x-axis and this one as the y-axis, and this point C00 is the origin. A point S, that is representing the focus, S dash is another focus that we will discuss later on. This one is the directrix, and the x-axis is cutting the directrix at point K. Similarly, this is second directrix, at the x-axis is cutting that second directrix at K dashed. Now if this is the ellipse, and if we consider any point capital A over here whose coordinate is taken as a comma 0, then the ratio of AS by AK will be equal to small e, as was discussed over here. PS by PM is equal to small e. So in place of P over here we have taken S, that is in place of P we have taken A, so AS by AK. Alright, this is the distance which was PM over here, and this is the distance AS which was PS over here. So AS divided by AK will be equal to small e, which is what I have written over somewhere over here. AS by AK is equal to small e, where E is the eccentricity and E is less than 1. So AK when brought this side, then we are getting AS is equal to EAK, that we have taken as equation number 1. Again, if you are considering S A dashed, means if you consider this point on the ellipse, then S A dashed divided by A dashed K will again be equal to small e, as was discussed earlier. Alright, the ratio of this distance and this distance will always be constant, that is equal to E and less than 1. Now from this one we will be getting A dash S is equal to E A dash K, that is taken as equation number 2. Once again, now equation number 1 and 2 are added. Equation number 1 and 2 are added. So I think it is visible to you all. Alright, 1 and 2 if we are adding, then AS plus A dash dash is equal to in this equation number 1 and 2, as plus a dash s, they are added and written over here, that is as plus a dash s, and in the right hand side e, it is taken common, ak plus a dash k, inside the bracket it is written over here, ak plus a dash k. Okay, I think it is visible. Now ak plus a dash k. Okay, let me draw this diagram over here again so that you will be able to understand it. So hold on.